Welcome to an example in which we have a tower on the side of a hill, 250-foot tower. So right here, this is the tower, and they're saying the height of the tower is 250 feet. Is located on the side of a mountain. See, this is a mountain here. That is inclined 31% to the horizontal. So 31% angle to the horizontal. It's a mountain that goes up at an angle of 31 degrees. A guy wire, that's this wire right here, is to be attached at the top of the tower and anchored at a point 47 feet downhill. See how this is 47 feet downhill for that wire? From the base of the tower. 47 feet from the tower's base down there. Okay, find the shortest length of wire needed. So in other words, what is this X? It's like a little triangle. We want that side of the triangle. That's basically what we're doing. Okay, well, to do that, how are we going to find that side of the triangle? Don't be thrown off by the tower. What you could do is you could just imagine a line that goes straight down to the middle. There's the height line. That's that side of the triangle. And we have this side of the triangle, right? And, okay, so we know this side is 250, this side is 47. Can we get the angle? Specifically, what can we do? Let me show you what we can do. If you, oh, here, let me back that up. If you put in this horizontal line right here, do you see that line? If this right here is 31 degrees, this has got to be 31 degrees also. See how that's the same exact angle? It's just the same line. Let me back that up. It's horizontal with the same line, horizontal. See how they have to be the exact same angle? If you want the geometry term, that's corresponding angles. That's two lines cut by two parallel lines, but they're both horizontal, right? So they're parallel, cut by a transversal. These are called corresponding angles. Anyway, I won't bore you with all the geometry lingo. You can see it, right? It's the same line cut by two horizontal lines. Those angles have to be the same. So that's 31 degrees, right? So wherever you go horizontal, the angle off that same line is going to be 31. Okay, great. Who cares? Well, then I can also find this angle. How? Well, those two have to make 90, right? It's a right angle. Why is it a right angle? It goes straight up. It's height, right? This. How do I know it's right? 250 is its height, the height of the tower. How do you measure height? If you want to measure your height, can you go diagonal down to the ground? If you go diagonally down to the ground, that's not height, right? Height has to go straight down. So this has to be a right angle because this is height. So it has to make a right angle to the horizontal. And this is I just brought in that, I just put a horizontal line right there to match that one. So that's got to be a right angle. So 90 minus 31, 90 minus 31's got to be 59 degrees. So this angle here has to be 59 degrees. So the total of the two is 90. Okay, great. Okay, you probably see that. So now I'd like to get this angle. Why do I want that? Because that's inside the triangle. How am I going to get that angle? That's going to be 180 minus 59. Why? Because these two together are halfway around. Right? Imagine if this was an axis system right here. These two together is 180 degrees. Right? They make a straight line together, don't they? They go from right here to right there. So together they're 180 degrees. So if you subtract 180 minus 59, you get 121. Yeah, 120 degrees. So that angle's got to be 121 degrees right there. So this is 121 degrees. So, okay, great. So I got that. Well, now I can find X. How so? Well, it's because we have two sides. We have this side and the angle in between. That means we can use law of cosines. We can't use law of sines, right? Because we don't have any side and opposite angle. Do you see that? So we cannot use SOHCAHTOA first off. Why can't we use SOHCAHTOA? It's not a right triangle. That's only for right triangles. And we also cannot use law of sines because we do not have any side and opposite angle. We never have a side and opposite angle, do we? We have this angle, but we don't know the side across. We have this side, but we don't know the angle across. We have this side, but we don't know the angle across. So we're going to use law of cosines. It's always a last resort when we don't have anything else we can do. So use law of cosines. That's what we always use for side, angle, side, right? When you have a side, and the angle in between. Call that side, angle, side. Two sides and the angle in between. We always use law of cosines. What's the law of cosines? Where is it? I have it in my notes here somewhere. There it is. Law of cosines. Remember, there's three versions of the law of cosines. Basically, A's got to be across from A, B from B, or C from C, with the other two sides in between. So I'm going to use, therefore, x squared, this side I'm trying to find right here, equals the other two sides, the 47 squared plus the 250 squared, it doesn't matter what order you do that in, minus 2 times one of them times the other times the cosine of the angle across from x, which we found to be 121 degrees, right? That's the one across from x. That's the one across from the guy wire in that little triangle on the hill, right? That's how law of cosines works. Any side and the angle opposite it for the law of cosines. X is opposite of the 121 degree angle. So that's it. Hit the buttons on your calculator. Crank out all that stuff. That's what I'm going to do right now. 47 squared plus 250 squared minus 2 times 47 times 250 times cosine 121. Make sure you are in degree mode because that's a degrees, not radians. I got it, 76812.39476, but that's x squared, so we got to root it, and then we can get x. So I'll hit second square root. Oops. Second square root of the answer. I use the answer button. It's quicker, more accurate. 277.15. I think they said 2 decimal places. 277.15 feet is the length of the wire. 277.15 feet is the length of the wire needed. So that's a pretty tricky question. We did a little bit of angle geometry stuff to find the angle right in here inside the triangle, and then we can solve for x using the